Hi, we're the 3D printed helmet team working in collaboration with ICAP. My name is Will Mikowski and I'm an interdisciplinary PhD student studying bicycle helmet design.
My name is Dr. Emily Kiefer and I just received my PhD from the Department of Biomedical Engineering and Mechanics.
And I'm Dominic Lopinto, and I'm about to graduate with a master's degree in mechanical engineering and industrial and systems engineering.
In 2018, 854 cyclists were killed in crashes with motor vehicles, which is a 7% increase from 2017. Safety is always a major concern for anyone riding a bicycle because crashing is always a possibility. When riding a bike, safety is primarily determined by the use of a helmet to protect the head from injury, because a helmet is the most important preventative measure for preventing and mitigating head injury during a crash. Traditionally, bicycle helmets have been made out of foam-based materials, specifically expanded polystyrene using injection molding. With new advancements in manufacturing, our team's goal is to explore how 3D printing methods might provide better options for safety.
Traditional manufacturing methods are slow and costly for iterating designs and product development. Exploration of additive manufacturing, 3D printing, could be a worthwhile exploration to accelerate both design and manufacturing processes. We are exploring how 3D printing methods might provide better options for reducing peak linear acceleration during an impact. In practice, this means designing complex lattices and mesostructures. We looked at rounded type 1 structures and diamond-shaped type 2 structures, comparing these with thickness gradients in an effort to optimize for energy dissipation.
Due to the experimental nature of the test coupons, it was important not to damage the equipment during impact testing, as some of the test coupons have completely failed in the past. So we designed an intermediary step for impact testing. This step, we're using an impact test rig, making sure that test coupons don't completely shatter, as well as measuring the displacement of the test coupons. Then if they pass this step of component testing, we'll be testing them at full velocity at Virginia Tech's Helmet Testing Lab, measuring for peak linear acceleration. So here's our impactor in red with our test coupon taped to the bottom of it. And this is our impact test rig to replicate previous testing that we've done. And here our goal is to make sure that the test coupons don't completely shatter, as we're going to find out now. Put it in the impact test rig and drop it. And there you go.
Test 2, straws. Nice.
Test 3.
Nice.